So let's look at set. A set is a collection of distinct objects. So what do we mean by a set is a collection of distinct objects? For example, look at the example here. We have a set of elements 1, 2, 3, and the other one is a set of elements 1, 1, 3. In this case, this one is a set and the other one is not a set because this one has what distinct objects or elements. So the one inside here is called element. So that is no repetition here. But here you can see we have one twice. So this one is not a set. So that's what we mean by a set is a collection of what? Distinct objects. The set of all states in Nigeria, to mention 36 states in Nigeria. So we can't mention a state like Lagos twice or your state twice. So we just have to mention all the states once. So that will be a set. That will form what? A set of states in Nigeria. So normally we set are often specified with curly brackets. So we call this bracket curly bracket. So an example of set is a set of even integers. So what do you mean by integers? Integers are numbers from 1 to infinity. So 2n is a set of integers, that is 2 times 1, 2. If I want to form an element from this formula here, so I will have 2 times 1, 2, 2 times 2, 4, that's another element, 2 times 3, 6, that's another element. You will notice that all those elements, they are even integers. They will give you integers. Where n here is a natural number. What do you mean by natural number? Natural number, a number that ranges from 1, uh, yeah, 1, 2, 3, 4, 5. They are natural numbers. Do you understand? So positive integers can be negative also. That is, you can have -1, -2 as integers. So that's why we have positive integers and negative integers. But natural number are always positive number from 1 to infinity. So let's look at empty set. Empty set. A set is said to be empty if it contains no element. For example, what can I use as an example? A set of air. You can't even measure an air. So like a set of air. It's an empty set. So an empty set is a set that has no element in them. So when we talk about a member of a set, for example, if you have a set 1, 2, 3, 4, 5 and B 2, 3, so B is a member of A. That is, we can remove B from A here. So because A here contains B, so we can remove B from A. So we can say that what we can say that B is a member of A. So what about equal set? Two sets A and B are said to be equal if they have exactly the same number of elements. If they have exactly the same number of elements, that is, they have the same element. For example, now look at A now. It has A, B, C, elements A, B, C, and B also have elements B, C, A. Even though they are arranged in different form, but it's the same element. Both of them have the same element. So these two sets now are said to be equal because they have the same element. That's equal set. It's a little bit different from equivalent set. A set A and B is said to be equivalent. Those ones, they are equivalent only if they contain the same number of elements. For example, if you have A, B, C, D, that's 4, and I have 1, 2, 3, 4. So A and B, in that case, they are equivalent sets. So we check on equivalent set later, you understand what I'm saying. So cardinality of a set, this simply means the size of a set. For example, if you have a set A now, which is A, B, C, so we have 3 elements in this set A now. The cardinality of this set is just 3. That's what we mean by the cardinality of a set. So what about intersection of a set? So two sets A and B are said to have an intersection. So their intersection exists if, for example, if you have an element 2, 6, 8 here as A and B as what 4, 6, 8. The intersection simply means what is common to both of them. That's what intersection simply means. What's common between these two elements now, A and B? 4 is common, 6 is common, 8 is common. That's why A intersection B there is 4, 6, 8. So intersection simply means what's common between two elements. That's what we call intersection. So they intersect each other. Where do they intersect each other? What number, what element makes them to intersect each other? So I hope you understand. So when you talk about union of a set of a set A and B is a collection of all objects that are in either set. Collection of all objects that are in either set. So you normally see people on the street, they have union. Okay, for example, let me use this example. If you have we have a union for tailoring. For those people that are tailors, we have a union, they have a union. So let's say that mechanics now, they have a union, that is where they come together and have meeting. So if they are going to have a union that's bringing that bring together people that are doing handwork. So for example, if I happen to be a tailor and also a mechanic, like I know how to sew clothes and I'm also a mechanic, and I attend both unions and I'm a registered member of both unions. So if these two unions want to come together and have a meeting, you will notice that I won't be repeated twice. I will be the only member to come there, even though I represent both tailoring stuff and the mechanic union. So the same thing is happening to union here. For example, if you have A as a member of 1, 2, 3 and B as a member of 2, 3, 4. So A union B is 1, 2, 3, 4, not 1, 2, 2, 3, 4. There won't be a repetition. Do you understand what I'm trying to say? So I have to find A union B. So it's a collection of all elements in A and all elements in B without repetition. That's what it simply means. So a universal set, this is a set of all possible objects. A set of all possible objects. For example, we have been using some alphabet as an example. That is, the other time I said a set A to be ABC, a set B to be this. So in the case of alphabet, the universal set is all alphabets. That is from A to Z. That will be your universal set. So your universal set is all possible outcome you can have in that set. That's universal set. So equivalent set, like I said the other time, two sets are said to be equivalent if they have the same number of elements. So a set A and B, they are said to be equivalent if they have the same number of elements. It doesn't matter if one is alphabet or one is number, or it doesn't matter if they look alike or not. But as long as they have the same number of elements, then we said they are equivalent. So enumerable set. So this is a kind of set in which the bijection between S and the set is a natural number. That is, one-to-one mapping of that element is a natural number. So when you talk about one-to-one mapping, probably, for example, if you have something like this, so here maybe you have X, Y, Z. So W, P. So here you have 1, 2, 3. So this is what we call one-to-one. So we call this one domain. We call this one codomain. So if an element in domain map to an element in codomain, just one element in codomain, we call it one-to-one mapping. Do you understand? We call it one, or we also call it bijection. It's also bijection. It's either we call it one-to-one mapping, so or bijection. So we are now saying that this is said to be equivalent if they have the same number. A set whose elements can be put into one-to-one mapping corresponding with a natural number is called enumerable set. So you can see that these numbers are natural number. I told you what natural number is. I told you what natural number is the other time. So the natural numbers are number from 1 to what? To infinity. So if an element here can map to a natural number, that is a set in which the element is what? The element in it is giving out a result as a natural number. We call it what? Enumerable set. So when you talk about a power set, yeah, we have given a set S. The power of S is a subset of a set S. If set S has n element, its power set is 2 raised power n. So if you have a set X, for example, a set S, let's say we have a set S to be equals to 1, 2, 3. That's set X now. So if the set S has n elements, so this set S have how many words? 3 elements here. 3 elements. So we say that the power set of S, the power set of S is equals to 2 raised power 3. So the power set we have 2 raised power 3 elements. 2 raised power, we can list it out. That's 2 raised power 3 is equals to what? That's 8, abi? You can list it out. You have in power set, the element you are going to have an empty set. That's number 1. Number 2, I don't know, maybe they are going to teach you that one. You're going to have each set in their self 1. You're going to have 2. You're going to have 3. You're going to have 1 and 3. So you're going to have 1 and 2. You're going to have 2 and 3. You're going to have 1, 2, 2 and 3. That is the set itself. So if you count it now, 1, 2, 3, 4, 5, 6, 7, 8. So these are the elements in the power set. So but we call this one power set. I just list it out for you. So what do you mean by subset of a set? A set A and B. So if we have a set A and B, A is a subset of B if each element in A is also in B. For example, now you have A to be equal to 3, 5, 7 and B to be equal to what? 3, 5, 7, 9, 15. So A is what? Subset of B because all the elements in A are also in B. Do you understand it now? So before you can solve any question on set, or before you can do anything on set, even to Venn diagram, you have to understand all these definitions.